Wherever you are looking at me from this moment, I want to greet you. Good afternoon. My name is Sir Kalu, a graduate of University of Nigeria, Sir Kalu. I studied physics education, and for the past 16 years I've been teaching physics. And most of my students from all the schools where I have taught, they are in demand that I should do a clarification, or I should teach this topic called simple AC circuit. And because of that reason, I am here at this moment. And I want to plead that you listen. I want to plead that you pay a clear attention. A keen attention is very important. If there is any question at the end of my presentation, you are free to put it on the comment section. You are also free to also make me identify any topic that you would want us to discuss after now. Now, simply, we are going to be discussing simple AC circuit. What is AC? AC simply means alternating current. Alternating current. What is the full meaning of simple AC circuit? Simple AC circuit simply means circuit through which an alternating current flows, such as used extensively in telecommunication, in radio, in television, in computer technology, even in medicine. It is also used in power transmission. This is the reason why in our country today we have a company called Power Holding Company. Power Holding Company. The energy they provide uses simple AC circuit. And again, AC circuit current varies sinusoidally. It varies sinusoidally. It varies sinusoidally. And again, we need to relate it to so when we say that simple AC circuit or the current varies sinusoidally, it means that the current through which the circuit flows must get to the peak or to the amplitude. It must get to the peak. This is the peak. This is called the peak current or the amplitude. Alright, when you get to this point, we always symbolize it with I naught, which is called peak current. So before we can now say that the current is sinusoidal or it varies sinusoidal, it means it must get to the amplitude or to the peak. And this is the reason why it is used in the power transmission, this is why it is used in radio transmission, it is used in television, it is used in telecommunications, and many other power consuming devices. Today, I want to be discussing freely what is peak current. We are also going to look at what we call root mean square. Root mean square current and root mean square voltage. Whenever we talk about peak current, we are referring to the effective value of current. Effective value of current. The peak current and the root mean square value of current. These are one of the nomenclatures of simple AC circuit. Nomenclature simply means naming. How can it be named? How can it be identified? What am I going to call it? So in that regard, we call it what? Peak current or root mean square current. Now, peak current simply means effective value of current. Effective value of current. I'm always symbolizing with what? I subscript not. I subscript not. The I represents current. But because we are looking at what? The peak current, the current at the amplitude, as it varies sinusoidally. As it varies sinusoidally. The apex, the peak, the amplitude is now said to be what? The peak current. And we say it is the effective value of current. Now we'll now look at what we call the root mean square current. Root mean square current is always symbolized with I subscript RMS. This I represents current, while this R here represents root. This is mean and this is what? Square. And we always write this formula to be I RMS equal to I naught over root 2. Alright? That is the reason why it is called root mean square. Then in this case, as we continue, this is equal to IRMS equal to the peak current times inverse of root 2, which is equal to 1 I naught times 1 over 1.413, giving us times 0.7071. Now when we now have that our root mean square value becomes 0.7071 peak current. So this becomes the formula to calculate the root mean square value of current. Then if we're also calculating the root mean square voltage, we are also calculating the root mean square voltage. We now have that V RMS is equal to IR. Relating it to the Ohm's law. Ohm's law states that V is equal to IR, whereby this I represents the current, the R represents resistance, while the V represents the voltage. So if we now refer to this, we now have that voltmeter or the root mean square value of the voltage is equal to IR. Now we need to look at what we call resistance in simple AC circuits. We'll look at capacitors or capacitance in simple AC circuits. We will also look at inductance in simple AC circuit. That is what makes it different from other type of circuit. Remember, in our SS2, we were taught that a simple circuit is a combination or an arrangement of two or more electrical devices. A combination or an arrangement of two or more electrical devices. When you combine two of them, or when you join the two of them, or three or more, you have what you call an electric circuit. Now, in simple alternating current circuit, we now have three major devices that must be used. And these three devices includes one, a resistor to give us resistance in AC circuits. We have another device or another item called capacitor. We now have capacitance in AC circuits. Then the third one is inductor. Inductor, which is what? Inductance. Inductance in AC circuit. We will take them one after another. We're going to explain them one by one. In doing that, we will understand what resistor is. We will understand what capacitor is. We will understand what inductor is. A resistor is a device, is an electrical device that opposes the flow of current. In AC circuit, we have what we call reactance. In our last class, I was able to mention that a simple AC circuit is different from the other circuit, the electric circuit. But the only difference is that resistor is connected, capacitor is connected, and there is also what? An inductor that will be connected. So now when these three things are connected, we have what we call simple AC circuit. Now in this case, we need to look at what we call reactance. The concept of reactance is a very simple thing. What does it mean? Reactance simply means an opposition to the flow of AC offered by a capacitor or an inductor or a resistor. In this case, because it is an opposition means a hindrance to the flow of current. It does not allow the current to flow easily. That is why they are called what? Opposition. And the reactance is always symbolized with the letter X, capital letter X. We use X to represent the concept of what? Reactance. And reactance exists in the form of what? Resistance, capacitance, and the inductance. I mentioned this in our last class, where I mentioned that whenever we have a reactance in an AC circuit, it means that a resistor is connected. A resistor is connected in that circuit. Whenever we have a capacitance, it means that a capacitor is connected in that circuit. Whenever we talk about inductance in AC circuit, it means an inductor is connected. And then that will lead us to understand what we call reactance as a part, resistance as a part of what? Reactance. We are going to look at capacitance. And there is a name we call the capacitance. We don't call it capacitance again, but we call it capacitive reactance. We call it what? Capacitive reactance. Look at it this way. Capacitive reactance. At this moment, we no longer write it as C, but we use X subscript what? C, representing capacitive reactance. Then we will now have what we call inductive reactance. Inductive reactance. Inductive reactance is now symbolized with what? XL, whereby this C represents what? A capacitor. The L here represents what? Inductor. While the X represents reactance. Now, in the resistor is always symbolized with what? R. Now, when we have a combination of these things, 1, 2, we have resistor, resistance, capacitance, inductance connected in a circuit. It is no longer called one. You will no longer call it one name, but you call it what? An impedance. We call it impedance. Therefore, an impedance simply means an overall opposition. An overall opposition to the flow of current in a simple circuit. Let me repeat. I said it is an overall opposition of a mixed circuit containing a resistor or an inductor or a resistor. Or it is an overall opposition to the flow of current in a simple circuit, either when it is connecting 2 or the 3. But there must be more than one out of the 3. If 2 is connected, it is said to be what? An impedance. And we always symbolize it with what? Z. Capital letter Z. I believe that is clear. Now, going further, we need to identify the formulas that will be used in solving the problems on capacitive reactance, inductive reactance, and impedance, because this is very important. Now, Xc is what we use in symbolizing capacitive reactance, as I said earlier, and the formula is 1 over 2 pi omega t. 2 pi omega c. 2 pi omega c, while omega is equal to 2 pi f. 2 pi f. Then when we now substitute this into this formula, we have that x equal to 1 over 2 pi f c. This c represents, the c is what? Capacitor. Then the f is what? Frequency. Frequency measured in hertz. Always written as H subscript Z. Then, as we continue, this is the formula that we're going to be using. Any place where you're asked to calculate capacitive reactance. Remember, the symbol for reactance is what? X. But which of the reactants are we talking about? Capacitive reactance. And capacitive reactance is what? X subscript C equals to 1 over 2 pi f c. The presence of this capacitor is helping us to understand that capacitor is connected in that circuit. Remember, we said when resistor or capacitor or an inductor is connected in a circuit, they will have what's called simple AC circuit. Now, we also have inductive reactance. Inductive reactance. Inductive reactance is symbolized with X subscript L, because the symbol for inductor is what? L, measured in Henry. Measured in what? Henry. So the unit for measuring inductor is Henry, which we always use what? H to identify it or to symbolize that unit of measurement. Now, XL is equal to 2 pi FL. 2 pi FL, or which can also be written as X equal to omega L, where omega is equal to 2 pi F. So when we now replace this into this formula, we have that XL is equal to 2 pi FL as the formula to calculate inductive reactance. This is inductive reactance. Remember, we are discussing reactance. And reactance can be capacitive reactance or inductive reactance. Now, moving further, I said earlier that impedance is an overall opposition. Impedance is an overall opposition to the flow of the current in an AC circuit, especially when there is a mix of these items, a mix of these components, electrical components, like resistor, capacitor, inductor. So when we have two of them, when we have resistor and the capacitor connected, we can have an impedance. If we have resistor, capacitor, and inductor, we can also have what? An impedance. So now impedance is always symbolized with Z, meaning that this Z will now be R squared plus XL minus XC all squared. This is a formula to calculate impedance. This is a formula to calculate impedance. The Z here represents what? Impedance. The R here represents resistance. The XL here represents inductive reactance. The X here represents capacitive reactance. This can also be written as Z equal to square root of R squared plus XL minus XC all squared. This is also the formula to calculate impedance. Above all, the unit for measuring all the reactants, the unit for measuring all the reactants is ohms. Meaning that if you have capacitive reactants, it's measured in ohms. Inductive reactance is measured in ohms. I want to stop here for the moment. In our next class, we are going to be discussing formulas to calculate the current, formulas to calculate the voltage, formulas to calculate also how to apply the formulas we have just discussed today. In our next class, do well to comment by indicating your questions, indicating what you did not understand clearly, that you needed a further explanation. God bless you, because you are my friend. I always love to discuss with my friends every time. Thank you very much. Have a nice day.